The BeagleBone Black is truly a cool little piece of hardware. Not only is it a single board Linux computer, but it has a lot of different I/O available, including analog inputs. This makes it very useful for a hardware junkie like myself. In this video, I'm going to show you how I designed a hardware platform that connects to the BeagleBone Black. This design includes configurable analog inputs, relay controls on the board, current measurement ability, and a breakout of all the other I/O available. As usual, I want to start with a circuit analysis. Here we have the two large headers. The BeagleBone Black has two main headers that connect all the GPIO. And here I have all the net listings out on my schematic showing what's connecting to each one of those pins. From here, I can go out to the individual circuits. Over here we have a relay circuit. And actually on this board, I'll have 4 relay circuits. All of the relays are able to switch up to 220 volts AC and controlled by one of the GPIO lines. A few of them have current sense circuits, where I can actually measure the AC current going through into the load. This current is fed back into an analog input. Each relay is configured the same with a normally open and normally closed, and a flyback diode. When the field collapses around the inductor after it's turned off, that diode will protect the input. I also have an indicator LED, and the whole thing is controlled with a transistor. I break out all the serial interfaces into one header, all the available serial interfaces. This allows me to connect any peripheral I need on the side. One serial interface I use, the TX, to control a 3.3 volt serial LCD that I'll locate on the board. All of the other GPIO that I don't use on board are broken out into headers, much like what you would see on an Arduino or similar chip. Each header allows me to connect a wire from them over to a breakout board or a breadboard. I also include analog sensors as a fixed sensor and as adjustable sensors. Most of these adjustable sensors have a 3-pin termination, 2 jumpers to control whether they are 5 volt or 3.3 volt controlled, and the output line going into the processor. These lines are adjustable by dual resistors, so I can scale them for the input. One sensor that's on the board in a fixed position is this temperature sensor. I again can scale the input for the analog input, but I can determine the temperature around the board. The BeagleBone Black has a few pins that can be used as an I2C interface. I break out this interface both in connector fashion to connect things off the board, connecting all the bus, the SCL and the SDA, to a temperature IC, so I can actually have another temperature value. That's useful for calibration. And a memory interface. This I can store some short-term data or even identifier numbers. I bring out the pin header that contains all the pulse width modulation to one header so I can find them all in one place. And feeding the whole thing is a power supply that gives me 5 volts, 12 volts, 3.3, and some LED indicators that allow me to see when all the power rails are functioning properly. To put all this together, I could do much like my ProtoShield project and wire it in by hand. However, there's a lot of connections going on this board, and it would be nowhere near as neat looking as this, and it would probably drive me crazy trying to do it all. For this project, I'm going to step it up and make my own printed circuit board, and this is something you can do easily. There's a lot of software out there that allows you to do the schematic and then link it to the program that does the layout. Therefore, everything runs together and it's easy to port from one to the other and make changes. This layout format allows you to see where parts are placed and see where the routing and the traces go. This does all my wiring for me and gives me a really neat product at the end. It's like Christmas when the board that you designed shows